Hi, am I audible?
Yes, Akka.
Yeah, okay. We'll wait for 5 more minutes. After that, we'll start the session. Let others join until that. Okay. So, hi, I'm Mohana Priya S. I'm the AWS Cloud Captain of St. Joseph's Institute of Technology. Good evening, everyone, and I'm so happy to all of you join here for this session. Today, I'm and my core team members, Jefferson and Manashaa, will take you and we'll explore what is AWS and the cloud concepts today. Meanwhile, you have any doubts when the session is there, you can stop us at any time and get clarified your doubts. Okay. Jefferson will start the session. Jefferson.
Okay, I'll just share the screen and you just let me know if it's visible or not.
Yeah, sure. Yeah, it's visible, Jefferson. Okay. Let's start. Okay, if you have any doubts, stop us at that moment itself and get clarified. Okay, don't hesitate to ask any questions. We'll be very friendly, and our ultimate aim is to clearly explain the concept so that you can able to apply that in your projects and tasks or POC, anything else. Okay. Yeah, Jefferson,
So,
you can start.
so good evening, everyone. So now we'll be starting our cloud classes in the topic cloud computing, and it would be more specific into AWS. So before deep diving into, am I audible to everyone?
Hello. Yeah.
Okay. So before deep diving into cloud concepts and what cloud computing is, first we need to understand how companies used to build systems earlier, even before cloud computing existed. So before cloud computing, what we had is a traditional infrastructure, that is, the companies used to buy everything themselves. They used to have the physical service. They used to provision everything themselves. The networking equipments, racks, the storage devices, power supply, and even the cooling systems. All of this had to be set up inside their own office and data centers. So everything was owned and managed by the company itself. If something broke, the company had to fix it. And if something needed an upgrade, the company had to plan and pay for it. It would take weeks and days of time, and it's more of a headache. So we had certain problems which we need to get rid of. So cloud computing came as a solution to these problems. So first we'll look into the problems in the traditional infrastructure which we had. Cost problems, that is high upfront costs. The cost problems are mostly focused on more like resource wastage. How the resources is wasted in the traditional infrastructure is we spend more even before the business grows. For example, if I'm starting a MNC or something, and uh, I need to launch a product, I buy servers, a lot of servers, and expect that my product would grow someday, and I would be buying a lot of servers and the physical system that are required, the whole infrastructure that are required for the product. So at the end, only little amount of the physical servers or the product which I launched would utilize the server capacity, and a lot of space would be wasted. So this would obviously consume more cost, because the infrastructure which we set it up already is a huge infrastructure. So that obviously would cost more, and it is more of a wastage of resource. The scalability issue is also another concern. So limited scalability is there in case of traditional infrastructure. How scalability is limited in traditional infrastructure is, uh, in traditional infrastructure, we can't scale up or scale down based on our need. Let's say a huge amount of traffic, or let's say more number of users are using our application in a certain time. We can't increase the CPU capacity for a specific time. And when the users are limited, or when the users are low, we can't decrease the CPU capacity when we need. So this is a problem. And of course, the servers are overutilized or wasted when we are not using it itself. So that's a problem in traditional infrastructure. The other problem would be maintenance issue. Let's say we have a lot of hardware, like and power supplies required. As I mentioned, we need a lot of physical servers as well. All of this should be maintained on a daily basis, and we need to keep a check on that. Only then we can ensure that our application or product is working properly, and it's all running good. So without this, we can't ensure that our product is properly functioning. Let's say we are all aware about the failures which we had now, even in the cloud platforms itself. Recently, we had the downtimes in ChatGPT and several other streaming platforms also. In traditional environment, it was even more worse. So we can see the problem, and we obviously need a better solution for that. That's why the cloud platform came in. And also the other disadvantages are the companies spend more time on this maintenance purpose, rather than focusing on the product or launching new products. So they need to hire employers even for the maintenance purpose alone. They spend money for the human resources uh, for just maintaining the servers and taking care of that. So this is a problem. So cloud computing came as a solution for all these problems. So what is cloud computing? Now we'll see what is cloud computing and how this solved this problem and how it's more efficient than the traditional infrastructure. Cloud computing is the on-demand delivery of computing power, storage, and other IT resources over the internet. It allows users to access services through a pay-as-you-go model. So what pay-as-you-go means? Pay-as-you-go means you pay for only what you use. So in the earlier case, which we saw in traditional infrastructure, you just get a lump of servers and it's not fully utilized. That's not the case in cloud computing. You just use only the resource which you need, and you only pay for the resource which you use. So when you need, you can scale up, and when you don't, when you need only less amount of service, you scale down based on your requirement. So that's a huge benefit in the cloud computing concept. And also the physical infrastructure is not managed by our side. Security problem, everything would be taken care by the cloud provider itself. And the scalability and flexibility are all the services that are provided by the cloud computing provider itself, cloud provider itself. So this should before I said that we need human resource for maintaining the infrastructure itself. So the companies don't need these human resources anymore. They can just focus more on the product, and the IT world boomed rapidly. This is the reason. And other issue is in traditional infrastructure, we had global limitation. Let's say we have our data center in a specific region, kilometers away from in another country, and we need to access it from a far location. The latency would be so high because the globally it is limited to a specific area and it's not a global delivery. So cloud computing solves this issue too. So the deployment models in cloud computing. So these are the three major cloud deployment models: public, private, and hybrid. So before that, anyone have any doubt in the topics explained so far? You can ask me.
No, bro.
Sure. Hello.
Sure, sir. Sure.
Okay. So that now I'll be explaining about the three major cloud deployment models: public, private, and hybrid cloud. Can anyone tell me what's public cloud, or just tell me in which category AWS would belong to? Public cloud, private cloud, or hybrid cloud? AWS belongs to which of this category? Can anyone? Don't know. So I'll just tell myself. So public cloud means that it is publicly available. The resources are shared to users and it's available online. And it has limited amount of security and all. But AWS, Azure, and all these things will be under public cloud itself. So public cloud is the most popular one, and we are also using public cloud ourselves. And we need a private cloud also. Let's say we have a company and we need a dedicated cloud environment for ourselves because we have highly secure data and we need dedicated cloud for our company alone. Then what we'll move on to is private cloud. That's the case which we look into private cloud. But for normal cases and deployment purpose, we just look into public cloud alone, and that's enough. But private cloud is also preferred when the security aspect is highly matters. So the third part is hybrid cloud. Hybrid cloud is the combination of both of these, that is public cloud and private cloud. The combination of both of this means it would take the advantage of public cloud as well as the advantage of private cloud. So what is the advantage of public cloud? We have high scalability, completely managed service, and in case of private cloud, the security aspect is high, and we get a dedicated environment for ourselves. In case of hybrid cloud, we will get both of this. Our environment is highly scalable, and we get our environment is managed by themselves, and the private cloud benefits such as high security and confidential data would be secured and preserved. All these would be in private hybrid cloud too. So hybrid cloud would have the benefit of public cloud as well as the private cloud. So we'll move into next topic. So now we'll look into the characteristics of cloud. So what are the characteristics of cloud? We just saw what is cloud computing and the cloud deployment models so far. Do you have any doubts in the cloud deployment model, the three types? Can anyone differentiate the three model? Hello, am I audible?
Yes, you're audible. Guys, if you have any doubts, unmute yourself and ask, or else you can also leave your questions in the chat box also. Okay, we'll see that and we'll answer your questions.
No messages so far. Anyone have any doubt so far?
No.
I continue. So I think you are also really aware of these topics. It's more of a repetitive concept, I guess. So that's why no one's answering me. So characteristics of cloud computing. So these topics would be common in the CLF exam, which you'll be writing later, the cloud practitioner. So basics are the most important question. Basic questions will be most importantly asked in the CLF exam. So you should be clear in the basic concepts and the AWS console also. So characteristics of cloud. On-demand self-service. What does on-demand self-service mean? What does on-demand mean? On-demand means we don't have to wait for the result. That is, we don't have to request and we don't have to wait for a lot of time for our request to be granted. We just go into login into our console and we just click on the services and we can use it ourselves. No need to talk to anyone or raise a request or anything. The services would be available on demand anytime, and we have access to it. That's what on demand means. And we have network based access, broad and wide network based access. We get access from anyone anywhere. That is, let's say if you're in office, home, or another country too. We just don't need a specific only in this place we can use cloud. That's not like that. We can use cloud from anywhere. We just need our laptop and we just need a good internet connection, and that's all. We can use our console easily or CLI anything. So I think you are all aware of infrastructure as service, platform as service, and software as service, which is common in cloud. That is, cloud provides infrastructure as services too, and platform as services too, and software. And software as service means the entire service is managed and entire thing is by the cloud provider itself. And also, we can access cloud in console, CLI, and SDK. Initially, you'd be focusing more on console, and when you're highly comfortable with console, then you can move to CLI and land the terminal. And other than this, we also have infrastructure as code tools like Terraform, where you can just write the scripts yourself, and it will create the entire service itself. You don't have to click here and there. You just need to understand the infrastructure and you need to write the script. That's all. So first you need to be thorough in the console for that, and you can move on to further tools. So the other characteristic of cloud is multi-tenancy and resource pooling. What does multi-tenancy and resource pooling means? The resource is shared. Let's say we are a user, and your friends, every of your friends in cloud are a cloud PEP or a user in a cloud computing user, because everyone have an AWS account. But we feel like everyone have a dedicated server and everything managed, because that's how when we work we feel. But that's not true. There are groups of servers and physical infrastructure there, and the resources is shared to each one of us. That's what multi-tenancy and resource pooling mean. But we feel like it is specifically dedicated to us. That's the superpower of cloud computing. Rapid elasticity and scalability. It's highly flexible, highly scalable too. That is, let's say when we have some less users using our application, we just need few amount of service. So we have auto scaling groups too. We just scale down when we need only less amount of service. Then we scale up when the users are high. That's highly possible in cloud computing. And measured service. As we saw earlier, we pay for only what we use. We don't pay higher than that. And in free tier also, for learning purpose, they have provided us many things fully free. In free tier also, we'll be having paid services too. You should use carefully. So now we'll look into the advantages of cloud computing. So we saw certain disadvantages in the traditional infrastructure. You remember? First, I said, talked about the disadvantages in traditional infrastructure. So I said cloud computing overcomes all those disadvantages. So that's the advantage. Simple. So in advantages, we'll see cost efficiency. First, I said you just pay for unnecessary servers and unnecessary management purpose and all. But in case of this, we only pay for what we use. So cost efficient. It is more cost efficient and we can save a lot of money. Benefit from massive amount of scale. That means we benefit from large amount of scaling purpose. That is, more amount of users would be using cloud platform, and we would benefit from that. And scalability, as I said, we can scale up and scale down when we need, based on the traffic or user requests. And high availability and reliability. The other main aspect is the application should be highly available. What highly availability mean? High availability means what when we call an application highly available. Let's say a data center or in a specific location got damaged. Let's say in a specific region, in a specific availability zone, a data center got affected. In that case, our application shouldn't be crashed or shouldn't go down. It should still be available and the user should still be able to access that. We recently had problems in Cloudflare, I guess. So that's when the application loses the high availability aspect. But we should ensure that our application is highly available and reliable, even in case of any disaster or any problem. So we need to deploy it in multiple regions or multiple availability zone, and multi-region aspect would make it highly available. If one region connection or one region is affected, we can still take the backups from another region, or the application should be still available in another region. And going global in minutes. What does go global in minutes mean? Are you available? Like, are you aware of the CloudFront, the content delivery service? That is, let's say, here we'll see. Here we have edge locations. So what is the purpose of edge locations? Edge location means it's the near available data center or a near available resource from AWS. So we can access our content so fast from the place which is available nearby. And going global in minutes mean we have global infrastructure. Let's go to the console. I'll explain you. Here we have, is my console visible? Hello?
Yes, it is visible.
Yeah. So here we have different regions, and the availability zones of these regions should be available when you go into VPC and create subnets, and several other resources. We'd be given options to choose.
Jefferson, 1 minute.
Okay.
Madheshwaran, I think so. You raised your hand. You have any doubt?
Do you have any doubt? Madheshwaran.
Am I audible, Madheshwaran? Do you have any doubt? I hope you don't have any doubt right now. If you have any doubts, you can ask it later, okay? Or otherwise, you can put it in the chat box. I'll see that and I'll ask Jefferson to answer it, okay?
It's better you unmute yourself and ask, because that's how you get more involved into this. So if you have any doubt, you can unmute yourself and ask anytime. So as we saw in the console, we have specific regions, and in those regions, we'll be having availability zone. Edge location is a separate concept. So edge location means for uh, highly available and highly fast data, that is low latent data, we use edge location, because for streaming purpose, we need continuous flow of data, and it should be so fast. So in that case, we use edge location, and it should be also available everywhere. So in all over the globe, we have different edge locations, and it would be fast for every users everywhere. That's what it means. So now we'll look into the AWS global infrastructure. The AWS global infrastructure means we have data centers located across multiple geographical regions worldwide. So the main concept would be region, and inside the regions, we'd be having a number of availability zones. I'll be moving here. It will be more easy for me. So, oh yeah, is it visible? This is the AWS global infrastructure. We have AWS regions, availability zones, and then edge locations, or we can call that as point of presence too. So we have regions in several area, and AWS has regions all around the world. So what does a region mean? A region is a cluster of data centers, and several AWS services are not global and it is region scoped. Only some services like IAM or just IAM and Route 53 are global. All other AWS services are region scoped. It's region specific and has its unique characteristics in region. So how to choose an AWS region? We choose the region which is nearly available to us. Let's say Mumbai would be a good option for us. But as I said, most of the services are region scoped, and some of the services wouldn't be available in our region. In that case, we move to the regions which has those services available. Now, availability zones. Each region has many availability zones, usually 3. The minimum is 3 and the maximum is 6. It can have up to 6 availability zones. We'll move back to the presentation. Yeah. So availability zones are isolated data centers connected with low latency networking. As I said, every region would have numerous availability zones. And when we create subnets in VPC, we would assign an availability zone to that subnet. For example, a subnet can have only one availability zone. We can't give multiple availability zones, because that's how it works. And edge location enables fast content delivery and low latency using Amazon CloudFront. As I said already, CloudFront is a content delivery service, and edge location is the purpose that it gives content delivery with low latency. That's all. I'll just give you a quick tip to learn. Are you all listening? Hello? Anyone
Yes.
just unmute this? Okay, good. So let's you can just go into your console. Here you will be having this section, this dotted section. Here you will be having analytics application. When you click analytics, you will have the services related to analytics. And similarly, for every purpose, you'll be having services that are related to that. Let's go into a service, for example, VPC. You would have this section in the site. You need to be aware of all these topics and the purpose of this topic. You need to have hands-on knowledge in all this. At least in the core AWS services, you need to have knowledge on these topics. So that's all. Next topic should be continued further. Thank you.
Yeah, thank you, Jefferson. Is my screen visible? Am I audible?
Yes, Akka.
My screen is visible, right? Okay. Till now, you have any doubts, or else you need to repeat any topic again? If you could say that, we will definitely do that for you. Do you have any doubts? Do you have any doubts? Um, like, do you want us to repeat any topic again? I hope everything is clear. Okay, we'll move to Elastic Compute Cloud. Okay. Well, EC2 instance, we used to call this as EC2 instance, virtual server, virtual machines, etc., etc., etc. So this is basically a virtual server that is provided by AWS, okay, where the users can run the application by configuring the compute power, memory, storage, and networking resources. So basically, when you have an application, you would probably deploy that application at a server, right? So, as Jefferson said, when you go for on-prem or private cloud, you have to set up those servers, those hardwares, and the power, the memory capacity. Everything is it is something your responsibility that you need to set up, and you need to configure it, and you need to maintain it. Obviously, at the end we will be billed with more money, and also maintenance overhead, etc., etc., etc. So when cloud came into existence, it provided a very cost effective solution. Okay, it provided the IT resources such as compute, memory, storage, everything over the internet, such that people can make use of it. Okay, so this is what Elastic Compute Cloud is: something, a virtual server that is provided by AWS. Okay, so these virtual servers are built with the pay as you go basis, which means you only pay for the resource you utilize. Okay, so at any time, if you want to scale up your virtual servers, you can do it. It is completely allowed in cloud computing. So if you want to do the same in on-prem, then it is not possible. You need to again put money, and people maintain it. So when it comes to cloud, that is not going to be a scenario. So this is what cloud's major advantage. So this virtual server is defined or classified based on two types. One is based on performance, and another one is based on pricing models. First, we'll see how it is classified based on performance. We have general purpose EC2 instances, compute optimized instances, memory optimized instances, storage optimized instances, accelerated computing instances. We'll see one by one. Okay, so general purpose instances, basically this type of instances will provide a balanced CPU, memory, and networking. Okay, so far I was saying it provides EC2 server is something, it gives you compute power, memory power, and networking and all. Do you have any idea that what is this compute power or memory or networking? That's what does it actually mean? Anyone? Anyone? Any idea? Or
Provides RAM or ROM.
Okay, memory, it means the RAM. Okay, the compute power.
CPU.
Okay, CPU. The networking and all. It's okay. Basically, networking is nothing but how the data gets transferred in and out through the EC2 server. How it comes into the EC2 server and how it goes out of the EC2 server. Okay. Yes. So some applications might need high CPU. Some application might need high RAM. Some application might need high read and write operations to the disk. So based on that only, this EC2 instances are classified. So general purpose instances, they provide balanced CPU power, memory as well as networking capabilities. So such general purpose instances are suitable for everyday applications. For example, I can say you have any kind of web applications, so that kind of applications can be hosted on this general purpose instances. Okay, they don't need any kind of high CPU or memory. Okay, so general purpose instances are ideal for everyday work applications like websites or web application, any kind of web applications you want to host. Okay, then compute optimized instances. So this kind of instances are designed for applications that need high processing power, which means high CPU. Okay, so let's say you have any gaming application in your hand, obviously it needs high CPU, right? So such kind of applications are deployed in compute optimized instances. Okay, then memory optimized instances are designed for application that needs a large amount of memory, which means RAM. Okay, so this kind of instance is the best choice for application that stores and process data in memory rather than on disk. Do you guys have any idea on what is in memory? Am I audible?
Like in primary memory, like RAM.
Yeah, exactly. In memory, in a sense, you won't store the data in the disk. Instead, you will store the data in the RAM. Okay, so what is the advantage of having in memory databases? Exactly. It would be very fast. Retrieving the data won't take much time. Very fastly you can retrieve. Great. Okay. So the application which need in-memory databases, which need in-memory storage or the applications that utilize in-memory databases, it can be deployed on memory optimized instances. For example, I can say Redis, Memcached. These are all in-memory DBs, so we can use that. Okay, then storage optimized. These kind of applications are designed for this EC2 instance is designed for application that needs high disk performance, meaning some applications need high read and write or very fast read and write operations to be performed on the disk. So such kind of applications can be deployed on this storage optimized instances. And the last one is accelerated computing. So far, we have seen instances with CPU, RAM, and networking. These accelerated kind of instances provides GPU capabilities. So such kind of instances can be used for training machine learning models, because when you train machine learning models, obviously when some of the models need GPU capacity, right? GPU capabilities and capacities. So such kind of instances can be deployed on accelerated computing instances. Is this clear, or do you want me to repeat that, anyone? Is this clear? Okay. For everyone, it is clear, right? Okay, guys. Okay, guys. Thank you. So these young families, T families and all, have you heard of the T2 micro, T3 medium, that instance type? I can show you in my console if I'm not wrong. Here, we call this T2 micro, right? So this T is called the family, and this 2 defines the generation. Okay, this is the second generation instance, and this micro word, it shows the size of the instance. Okay, basically this will differ: micro, T2 dot micro, T2 dot small, T2 dot medium, T3 dot medium, likewise it will go. Okay, so that is what here mentioned. Okay, T and M families falls under general purpose, C type families and all falls under compute optimized purpose, R and X families falls under memory optimized, and IDH storage optimized, P, G, D, F and V families fall under accelerated computing. Okay. Okay. So far, we saw how the EC2 instance is classified based on the performance. Right now, we saw how it is classified based on pricing models. First one is on demand. On demand instances are nothing but you use that instance and you pay for what you use. Okay, basically it will be billed per second. Okay, per second, how much have you utilized, how much CPU time you have utilized, it will be billed. And the second one is reserved instances. Reserved instance means you will reserve a particular type of instance. For example, I showed you T2.micro, right? You will reserve that T2.micro. I'll use that T2.micro for 1 year. Okay. So if you give a promise that I'll use only this T2.micro in this particular region for 1 year, and you can based on that you will be billed. Okay, basically reserved instances will give you up to 72% discount when compared to on demand. Okay, basically but sometimes you will be billed even though you don't use that. Okay, and there are something called convertible reserved instances. Here in reserved instance there is one disadvantage. When you opt for a particular type of instance, you can't able to change that. For example, you reserve T2.micro instance, you want to change it to T3 means you can't do that. In convertible reserved instance, you can able to change the instance type or family and OS anything. Okay, you can able to change from T family to M family, you can change the size from micro to medium, or you want to change from Ubuntu OS to Linux AMI, anything you can do in the convertible reserved instance. Okay, then savings plan is something, you will give AWS a promise like you will use this resource for a particular time. For example, let's say I'll use the EC2 instance for 1 hour and you can bill $1 per hour. Okay, so what they'll use is you'll use for 1 hour, and for that 1 hour you will be billed only $1. Okay, not more than that. If you go beyond that 1 hour, you will be billed on demand basis, pay as you go model. Okay, so this is what savings plan. And on spot instances means AWS has a lot of EC2 servers, right? And not all of the users are completely utilizing it. There are so many idle instances. You will request AWS to use that unused capacities. Okay, so this spot instances gives 90% of discount when compared to the on demand pricing. But one major problem is at any time your instance, the capacity provided to you will be taken. Okay, so it is only suitable for batch works. Batch works means you will schedule that work and it will complete quickly. Okay, it won't take any too much of time, and it won't take any high availability and all. So for such batch works, spot instances are good. The next one is dedicated host. In dedicated host, you will be provided with a complete physical server. Okay, that physical server is not shared with any AWS customers. Okay, you decide how the server wants to be, and you decide what are the configurations needed for that server and all. Okay, this is what dedicated host, and you can launch multiple instances on that server. Okay, and there is another one type also called dedicated instances. In dedicated instance also, you will be given a dedicated hardware, but it is completely managed by AWS. Only AWS decides what type of hardware to give and where to place your EC2 instance. Okay, so this is what the pricing model of AWS EC2 instances. Do you have any doubt in this? Do you have any doubt, or you want me to repeat anything again? Okay, I'm so happy that all of you are clear. Okay. Okay. Then EC2 storage options. Okay. So the first one is called Amazon EBS, Elastic Block Store. Okay, this is called a block storage for EC2 instances. It's more or less like a hard drive. Okay, when you connect a hard drive to the server, you can able to store that, right? So it is like an hard drive. So why do we go for Amazon EBS? Is basically when you stop the instance and start it again, everything will be lost. Okay, the RAM will be refreshed, it will be empty, and it will start reboot from again. Okay, that's why we go for Amazon EBS, so that if you store anything into that EBS, it will be persistent even if you stop or terminate your instance. Okay, so this is that is the purpose of Amazon EBS. And the next one is Amazon Elastic File. So the elastic file system is like a shared file storage. To be precise, it is a network file system. Okay, so again here also the data stored in EFS will be persistent, and this EFS can connect it across multiple instances. Whereas in EBS, um, in EBS there is one special feature called EBS multi-attach. Okay, only with that feature enabled, you can able to connect it across multiple instances. Okay, but on normal EBS you cannot do. You can attach only one EBS volume per instances. Okay, that multi-attach features and all you learn in the associate level. Okay, as of CLF level, you will learn about the normal EBS volumes. That EBS volumes are that can be attached only only to one instances. Okay, so whereas EFS can be attached to multiple file system. That is a major difference between EBS and EFS. And the last one is Amazon Instant Store. So here we saw a hard drive or network file system to store data, where Amazon Instant Store is not that scenario. Okay, in Amazon Instant Store, you will store the volumes in the RAM. Okay, the local storage, not on the disks. So once the instance stop, the data will be lost. Okay, that's one of the major disadvantage of Amazon Instant Store. But when compared to EBS and EFS, you can able to retrieve the data very fast in when you use Amazon Instant Store. But since it is the data is stored in the local storage, that is RAM, once the instance is stopped or terminated, you will completely lose your data. Okay, do you have any doubt in this? Yes, I think one have raised your hand. Yes, Karniha. Am I audible? Okay. Karniha, do you have any doubt? EFS, sure. So EFS are like shared file system. Okay, basically when you go for EFS, since it can be attached to multiple instances, you can able to share the data easily. That is what EFS is. Okay, have you seen in Windows you have file system, right? Likewise EFS. Is it clear? You want me to you know explain it once again? Clear. Are you sure? Is it really clear? Fine. Okay. So next, okay, we'll go to S3. Manasa, you can continue from S3, Manasa.
Sure, Akka. Am I audible?
Yeah, you're audible.
Just a minute. Is my screen visible?
Yes, it is visible, Manasa.
So, okay, let's start with Amazon S3. So, basically, Amazon S3 is used for your data storage, and the full form of it is Simple Storage Service. And this is one of the main building block of AWS, and it is one of the main building block, and it is advertised as infinitely scaling storage. Okay, so Amazon S3 is an object storage service, and you can store your files in it, and you can retrieve it, and you can store any amount of data. So that's the important thing over here. So many websites which you are using currently, and many apps which you are using currently, all of it uses S3 for as its backbone. So this is one of the main services, and in the certification exams, this is one of the main topics. Many scenario based questions will be asked from this, so you have to be clear. So yeah, so basically in this you can store your files, which is like data, and you can access it, and you can retrieve it at any point of time. So you will store objects in buckets. Objects is nothing but files, and the bucket acts as a directory, and each object will have its key. Key is nothing but like a long names with prefix, and these keys is like the full has the full path of your file. So when these keys will tell your SE3 where the file is stored. That's how SE3 understands it. And then uh, you can store up to 5 terabytes. That's like the maximum size. And if you have more data, you should upload it with in sizes, like you should upload it at multi-part upload. And then it offers high durability, availability, and scalability. These are like very important things. You have to understand that. So first, durability. What is durability? It ensures that your data is not lost or not corrupted. So you may ask, why is important? When, let's say, you have like your childhood photos, okay, and you store it in one hard disk, and imagine if it crashes. So all of your photos are gone now and you can't retrieve it or you can't see your photos again. But when you use to store this in your cloud, and it will get backed up in many regions. So even if it goes lost or corrupted in one of the regions, you can retrieve it from other regions and use it. So that's the important thing about durability. And then comes availability. It's availability can be explained as how often can your data or service can be accessed. So like when you wanna access your data, how fast can you access it and how much it is available, that's availability. And then scalability is how your system can grow or shrink smoothly. So you can upload your data, upload your files, and you can upload any amount of data, and you need not worry about the storage or like the space. So that's scalability. So you may ask why it is important. So for durability, uh, like many businesses, they will store customer details, financial records, and all. So if it is lost or it gets corrupted, many system, there will be interruptions in the businesses. So it's really important that the data is stored intact. And in researches, they will have like a decade long of data, so there will be so much data. So that will also remain unchanged. So that's the whole point of durability. And then why availability matters is, um, imagine you are opening an app, and it gets it's just loading, like it takes a lot of time to load. You're gonna get irritated, right? So when the app has to be accessible anytime and anywhere, so that's what availability is. There is difference between the durability and availability is, durability just says your data is safe, and availability is your data is accessible right now. So that's the difference. And then, as I said, your data will be stored as objects inside buckets. And objects is nothing but the files, and buckets is like the directory. And each object will have key, which is like the path or a label, and it tells the SE3 where to find the object. And then SE3 supports secure access control. So you can control who access the file. So this is also very important, right? Because when you store the data, it might have very important details in it. So you should give access to only the people who can access it, so it is safe. So it gives you secure access control. And encryptioning is like your data will get encrypted and you will have key for it only when you have the authority. And when you have the key, you can decrypt, and it will convert into a readable form. So that's encryption. And then you have versioning. So versioning is also very important because imagine you are storing information in your buckets, and then you're doing a change to it. And after some time, you are realizing you have made a mistake and you want to go back. Imagine now you don't have versioning, so the change is permanent and you can't go any further. So you have to redo a lot, and that's a lot of work, right? So if you have versioning, your what SE3 does is it will store each version. So whenever a change occurs, and it will store each of it as different versions. So if there is any change in one version, you can simply go back to the previous version and start from there. So it's very easy and convenient. And this is the basics of it. Any doubts so far, guys? Okay. So next is storage classes. These are different types of SE3 buckets which are available. You can, let's imagine you want to store your data, but let's take two persons, and each of them gonna store data. One of the person stores data and he accesses it like frequently, and another person stores the data but he doesn't access it as frequently. He just accesses it like every 3 months or 4 months. So here comes the storage classes. Uh, how it acts is like for different buckets, different types of costing will be available. So first is standard storage. In standard storage, uh, we will store data which are like frequently accessed, and your data will be 99.99% available. So when you access and store data frequently, it has to be available too, right? So in this you'll get maximum availability, and there will be low latency and high throughput, and it can sustain two concurrent facility failures. So this will be used in big data analytics and gamings and all. And then you have S3 infrequent access storage, one zone infrequent access storage, glacier storage, deep archive, and intelligent tiering storage. These are like primary classes, and there are subsequent classes within them which will not be necessary for your foundational like CLF certifications. But when you go to associate level certificates, you have to go in depth and read it. This is like a very important topic for associate level certs too. Um, Before going to that, I will show you how to like the console of creating the SC3. Any doubts, guys? Does anyone have any doubts, or can I continue? Okay. So this is the console. Wait a minute. So this is the Amazon S3, and you let me click. You have to click on create bucket. So when you look at this, one thing is when you create an bucket, it will get stored in one region. So you can select which region you have to store that in. You can change it. So you have different availability zones and you can change it according to that. And then bucket type, which is like you can choose, can either be general purpose or directory. I'm going to keep it general purpose. And bucket name. So there is a naming convention. There are few things which you have to keep in mind while you name a bucket. So there should not be uppercase, there should not be underscores. It should be between 3 to 63 characters, and it should not be an IP address, and it must start with a lowercase or letters. Okay. So I'll just name it my C3. And then here you can choose your bucket. Just a minute. I haven't created before. So then you will have your own object ownership. This controls ownership of objects, and it uh, who can who owns the object, and then you will have block public access settings for this bucket. And this is what I said, the bucket versioning. you can either disable it. So I have kept it disabled for now, so there won't be versioning available. But when you work on projects or something, you have to enable it. So if you do any mistakes, you can go back and redo it. And then you'll have tags. This is encryption. So first is server-side encryption. So this will be managed by Amazon S3 uh, itself. So you don't have to do the encryption. Amazon will encrypt and Amazon will have the keys. And next will be server-side encryption with AWS Key Management Service. So this is a separate service. So you can encrypt and you will have the key. It will know, Amazon won't know the encryption, or it won't have the key. And then you will have dual layer service encryptions. These don't have to go in depth, but I'm just saying. And then you'll have the bucket key. So that's all. You have to give all the details and create the bucket. I'll show you the differences of each types. So there are, I said as there are 6 different things. We'll see the differences of this durability, availability SLA, and availability zones, minimum storage duration charges, minimum billable object size, and retrieval fee. So yes, these are the storage classes, and you can move between this. You can change these classes manually using your life cycle configurations. When you do it manually, you have to keep changing the classes. But SE3 lifecycle configurations is like you will set up the lifecycle rules, and life cycle rules will monitor and it will automatically change the classes accordingly. I discussed about it, durability and availability. So durability, S3 gives high durability. It is like if you store uh, these much objects with S3, on an average expect, you will just lose one object every 10,000 years. So it is very highly durable, and it is same for all storage classes. And then availability, it measures how readily available your services is, and it is varies depend on storage classes. So first one is standard general purpose. As it said, yeah, availability is going to be same for all of the buckets, and it is used for frequently accessed data. So if you need to access the data frequently, you can store it in the S3 standard buckets, and then it has low latency and high throughput. Next is infrequent access. So this is for data which is less frequently accessed, but it requires a rapid access when needed. So uh, you are storing an object, but you don't use it in a regular basis. But it's like when you need it, it should be readily available, and it should not be delayed. So at that time, you will use infrequent accesses, and this is lower in cost than AC3 standard. And then there is like subclasses in this, but it's not necessary for your CLF. And then you have Amazon S3 Glacier storages. These are basically low cost object storage. It is meant for archiving or backups. So when you need to archive or backup your data, you use S3 Glacier storage classes, and the pricing is only for your storage and for your object retrieval costs. So it calculates for the storages, and it will cost when you retrieve the object back from the buckets. And there is instant retrieval, flexible retrieval, and deep archive. This is for long-term storage. Next is Amazon S3 intelligent service tiering. So first one is uh, small monthly monitoring and auto tiring fee. So you will just pay for like auto tiring and the monthly monitoring. Rest the SE3 will take care of it. It will move objects automatically between different access tiers based on your usage. It will monitor your usage, and if in case you are using an data very less, it will change its class and it will move it to different tier. So it will detect it and change it with no retrieval charges. Uh, and then these are like the different tiers: frequent access tier, infrequent access tier, archive instant access tier. So the first one is like default tier, and you can see like there is an categories, like if your object is not accessed for 30 days, it will move to infrequent access tier. Likewise for 90 days to 700 days. So it has like this timeline, and if you haven't accessed the data for that timeline, it will just move it to another tiering. uh, that's all is about intelligent tiring. So here is a comparison. First, let's look at durability. It's same for all the classes, as you see. It's same for the standard one zone infrequent access and everything. I guess I missed to say, like in one zone, it's only available in one availability zone. So if your data is gone corrupt in it, you can't access it again. And then we'll have availability, which is like how much your data is available when you need it. And it's nearly same for standard intelligence tiering and standard IA, and also for glacier instant retrieval and other things. It's just a bit less for one zone IA. And then availability SLA. SLA is nothing but service level agreement, which is given by AWS. It just says like it's an agreement given by AWS, like how much your data will be available, and it will be available for you whenever you need it. So for this, standard and glacier will have 99.9%, rest will have 99%. And then availability zones, you can see except for one zone IA, uh, rest of it will be stored in at least three or more than three availability zones. This is necessary, as I said, because if in one availability zone your data goes corrupt or lost, you can access it from other zones. And this is very important during any disaster or something. Like let's say if there is three different availability zones, and you have stored your data in three different availability zones, and in one availability zone, there was a huge cyclone, or like there is like a flood, so your server is down in one availability zone. But your user can't wait, right? So what S3 will do, it will take data from the rest of the availability zone and you will use it. So that's what is availability zone. But in one zone AI, your data will be stored in only one. And then minimum storage duration charge. This is like how long your data is stored, you will be charged for that. And you won't have it for standard and intelligent tiring, but for rest it will be charged based on days. And then you will have minimum billable object size. Again, standard and intelligent tiring won't have it, and for rest it will be charged based on KBs. And then retrieval free is the amount you have to pay for when you retrieve retrieve an data. And this is calculated per GB. like how much GB you have retrieved, you have to pay for this. So this is the comparison. You will get a lot of scenario based questions on this, so you have to understand like the different use cases of different classes. So you must understand when you have to use standard, when you have to use intelligent tiering. So for example, if they ask there's a person and they use their data frequently, what storage class should that person use? You have to go with standard. Or like there is a question like um, there is a person who needs to change their storage class automatically based on their usage. You have to go with intelligent tiering. So you have to learn that way, you have to understand each of it. I would say remember it using different use cases, and when you practice many questions you will be able to understand it. This is just an simple price comparison. So you can see how when you use different storage classes, it is charged differently. So choosing the right storage class is really important. So yes, I guess that's all from my part. Any doubts? Guys? Okay. Anyone else? Okay. I guess that's all from my side. If you have, we will say you there are different things like exam topics and all. When you, I would suggest you to learn all the concepts first, and then you can practice the questions, because when you practice the questions first, you might not understand it. When you have like you know when you understand the topics first and then practice question, you can understand why you are going wrong. So yeah, but there are different sites like exam topics and all, but I don't know if it's like free. And there are Udemy test practice tests and all. So yeah, we will guide you through that. Any other questions? Okay.
Okay. Any other
Mohana,
questions, guys? Shall we proceed to the next?
guys.
Okay, we'll
Oh,
proceed to next. Okay, thank you, Manasa.
okay, okay.
Okay, so far you have listened to what is EC2, what is S3, what is cloud, what are its characteristics, what are its advantages, that and all. So I want to ask one question: how many of you here are aspiring cloud practitioners, aspiring solution architects, aspiring developer associates, or how many of them for like these words are look like a Latin words? Okay, no idea about anything, huh? Just at least type something or unmute yourself, make it interactive. Oh, those concepts are over. Okay, now we are just going to explore what are the AWS certifications that are available, so that you can choose your interested one, and you can travel in that path. Okay, guy 3 ML engineer associate, great. Anyone else? Does anyone have? I know I need to achieve this certification. I need to do this solution architect. Great. Some other else? I think I would be very happy if anyone can unmute yourself and say, I want to do this. Like, if no worries, if you don't have any idea, also you can say, Akka, I have no idea. We are here to explore that. Then I could be able to understand and do that. DevOps engineer. Great. Okay. So all of you have already some idea about what is AWS and what are the certifications that are available, and we'll look into what are those. Okay. Okay. The foundational level certifications are like cloud practitioner and AI practitioner. Okay, so these are the no, as a student or as a beginner to AWS, these are the very foundational level certification that you can aim for. Okay, so this gives you a brief introduction to what is AWS, what are these services that are available in AWS. Okay, if you choose for cloud practitioner means you will be basically introduced to what are the services available in AWS and what is AWS, how it works, that and all. When you opt for AI practitioner exam, you will learn some basics of AWS services and more probably concentrating on machine learning path. Okay, what are the ML services available in AWS and how what are the uses of it, how we can use it. Okay, this is what the foundational level. Even I'm a certified cloud practitioner, and Manashaa is also certified cloud practitioner, and she's a certified AI practitioner too. And when after completing your foundational level, you can aim for the associate level exams. Okay, so in associate level, you have machine learning engineer associate, solution architect associate, data engineer associate, cloud ops engineer associate, developer associate, all those things. Okay, so in mostly ML, I mean machine learning engineer associate focuses on ML, and you will be trained to implement the ML workloads in AWS and all. Okay, so you will get hands-on training in that and all. And solution architect mainly focus on designing a cost and performance optimized solution for the problems. Okay, basically you will be designing the cloud architecture for deploying the application in such a way it is cost effective and also it is good in performance also. Okay, then data engineer focuses on AWS services that is related to data. Okay, here you will gain the ability to transform data, orchestrate data pipelines, and manage data lifecycle. These are the things AWS data engineer associate mostly focus on. Whereas cloud associate, previously it was known as sysops associate. Okay, here you will be learning to implement security controls, networking concepts, and maintaining the AWS workloads. Okay, and the developer associate, it mainly focuses on services like Lambda, CI, code pipeline, code build, those things. So here you will gain knowledge in developing and deploying your application using CI/CD workflows, that and all. After associate level, we have next level. Just a minute. Yeah. Okay. As a professional level are next to associate levels, where we have three certifications in professional level. One is Gen AI developer, another one is DevOps engineer, another one is solution architect professional. Okay. Here in Gen AI developer professional certification, you will design production ready Gen AI solutions. It is somewhat an advanced level. Okay, basically, this kind of certifications you can take when you have 2 to 3 years of experience in industry. Okay, that in that time these certifications will help you. And DevOps engineer, You will learn how to provision and operate, manage applications on AWS cloud using DevOps practices. Okay, that is what DevOps engineer professional certificate focuses on. Whereas solution architect professional certification focus on how to design complex, scalable, secure, and cost-effective architecture. And the last level is specialty certificate. We have ML specialty, advanced networking specialty, and security specialty, which here ML specialty focuses on implementing advanced ML models in AWS, and advanced networking specialty focus on how to design complex networking tasks and using AWS services. Okay, whereas security specialty focuses on implementing security solutions in AWS, learn data protection mechanisms, data encryption methods, and secure the internet protocols. Likewise, so as students, and you can begin your cloud journey with CLF certification. This is foundational certification, either CLF or AIF. Okay, this is what how I began my journey. Now I'm interning as a DevOps engineer in an IT firm, and I hope you can also begin your journey with the foundational certification, then move to associate and professional specialty as per your wish. Okay, is any doubt over here, or you wanna ask any question? Okay. Okay. Finally, thank you for your kind attention towards this entire session, and also some of you were very interactive. And I'm Mohana Priya. You can connect me on LinkedIn by scanning this QR. If you still not have followed our Cloud Club's meetup channel, scan this QR to follow it. And this is our Cloud Club's LinkedIn channel. Also scan this to connect with that if you have not done this so far. Okay. Okay, there is no mandate thing that you need to do this certification first and then associate, first foundational, then associate. Not like that. Now you are second years, I think so, right? Most of you are second years, some of you are third years or final years. Okay, you can opt for associate certification directly, but my recommendation would be completing the foundational one. Okay, when you complete the foundational one, probably you will have an idea about what is AWS and what are the services available in AWS. And then when you move for associate, probably you will feel little easier. You can also directly take associate certification. I've seen so many of my friends taking associate certification directly. As a beginner, when you opt for associate certification, obviously the effort you put for that would be it should be more. Okay, that's the difference. And for associate certification, you need hands-on practice also. That is very important. And most of the questions will be like scenario-based questions. Even in CLF also, you'll get scenario-based questions. Okay. Like saw so many EC2 instances, right? So based on, they'll give a scenario. You have a batch job, okay, that can be interrupted no matter if it gets stopped in between. Okay, what type of EC2 instance you would opt such that it would be very cost effective? Can anyone answer this? Okay, you have a batch job. Okay, batch job means it runs for only a small amount of time. Okay, if it gets interrupted in between also, there is no problem in it. This question is, you have to choose an instance to deploy it. Okay, such that the instance like it would be cost effective. Okay, is it clear, or do I want to repeat it again? நான் மறுபடியும் சொல்றேன், we have a batch job, okay va? Even though if it gets stopped in between, yeah, exactly, spot instances. So you have to understand, so we saw spot instances can be taken by AWS at any time, because we are using the unused capacity by requesting AWS. Okay, it can be terminated at any time. So you are so such kind of instances is good for small workloads, not critical workloads. Okay, so you have to understand the functionality of each service, how it can be used, and apply it in the question. If you do like that, means it will be very very easier. Okay. Okay. Then another question, if I would ask, you saw EBS and EFS. So can anyone say what is the difference between those two?
So the instance which is connected to one EC2.
Okay, correct. Like EBS
That
is
is
more
EBS,
like, okay.
and EFS means it's shared storage for many EC2s.
Okay, great. Like you can also like think, if you want to get it very quicker, means you can also think EBS as a hard drive in your system. Okay, it is attached only to your local system, not for other system. Whereas EFS is something, a network file system. It can be shared by other systems in a private network, within a LAN. Okay, so this is what the difference between EBS and EFS. Okay, great. And okay, let's say I have a object stored in S3. Okay, for some time I have not used it. But when I want to retrieve it, I want to get it, quickly. When I want to retrieve that application, it should be highly available, and I want to get that application. I mean, I have to get that object quickly. What would be the cost-effective storage or S3 class you would suggest? Okay, infrequent access. So like this only, the CLF questions will also be like that. Okay, so if you grasp the functionality correctly, you can able to answer the questions easily. Okay, so any other doubt you have, guys? Okay, is the session good? Any feedback from your side?
Yes, guys, if you say feedback, we can improve.
Okay, okay, thank you, guys. I hope you gained some knowledge today, and we'll connect on further sessions too. Okay, keep learning, and do some hands-ons also. If you have console access, do some hands-ons. That would be even improve your knowledge when you do practically. Okay. Okay, guys, thank you. Yeah, thank Thank you, Haripriya.